Today we're going to be learning about the volume of pyramids, so hopefully you all have your math notebook, calculator, and pencil ready to go. So, our goal, learn to find the volume of pyramids. We've already worked with prisms, and now we're going to kind of transfer that knowledge over to pyramids. A pyramid is named for the shape of its base. The base is a polygon and all the other faces are triangles. So if you look at the yellow one, it's a rectangular pyramid because the base is a rectangle. The pinkish red one is a triangular pyramid, meaning that the base is a triangle. And then the blue one is a cone, but we won't be calculating any of the volumes of any circular objects. So here's your formula. So the volume of a pyramid is 1/3 of the area of its base times its height. In numbers, you can see the one in the middle. Since the base is a rectangular base, it's a rectangular pyramid, so it's a 3 by 3 area of the base. So our area of the base is 9 units squared. When you take that times the height or the altitude all the way up to the tippy top peak of that pyramid, that vertex, which is a height of 4, so 9 times 4, and then you take 1/3 of that. You're dividing by 3. Okay? Anybody that wants to write down the formula, this would be the formula that I would like you to write down. Right here. So we're going to be using this today. Remembering that capital B is the area of the base. So it will either be a rectangle or a triangle base. So our first example. Finding the volume of the figure. Now when you start to look at these triangular pyramids, there's a couple different altitudes or heights that we are looking at because we have the height of the entire pyramid from the top vertex down to the base. But since the base is a triangle, we have to have the height of the triangular base. So I'm going to kind of highlight that for you or label it for you. So for this case, the area of the base would be calculated by taking 4 times 7, which is the height of triangular base, and then this 6 right here is the height of the pyramid. So when you have a triangular pyramid, you have the height of the base so that you can calculate the area of the base, and you have the height of the pyramid. So they've gone ahead and substituted in. This right here is B, the area of the base. The area of the base is a triangle, so it is 1/2 the base times the height of that triangle that's on the bottom. So 1/2 of 28 times the height of the triangular pyramid, which is the distance all the way up to that one vertex peak of the pyramid, times 1/3 of that, or divide that whole thing by 3. So 1/2 of 28 is 14. Using multiplication, you get 14 times 6 divided by 3, and that equals 28 centimeters cubed. Let's try another example. This is a rectangular pyramid. So we're going to find the volume. We're using the same formula. Because it's a pyramid, it is 1/3 of the area of the base times the height. Since the area of the base in this case is a rectangle, we'll use the rectangular area formula. So we can get length times width times the height of the pyramid and divide that whole thing by 3. So we start out with this formula, knowing that that capital B talks about the area of the base. So that means we need the area formula that matches the polygon of the base. So we can see that the length and width of this rectangular pyramid is 14 times 6. The altitude or height of our pyramid, right here, all the way up to this top vertex, is 10. When you multiply, you would take 84 times 10 and divide by 3. So everybody try that in your calculator. Try to get it to multiply out. Okay, so after you multiply, you would take 84 times 10, which is 840. You would divide that by 3 to get 280. The units are cubed, and again, the reason for that is because at this step right here, I'm not showing the labels, but these are all meters. When you take a meter times a meter times a meter, you get a meter with an exponent of 3, so meters cubed. Let's try another example. Okay, in this case, we have another triangular prism. So, the hardest part for you guys is going to be determining, like, where are these dimensions pointing to? If I were to highlight the base for you, I see the base in this case as being a triangle that kind of goes around here. All right, that bottom part. So with that being the case, that makes this 5 equal to the lowercase b, this 7 equal to the height of the triangular base. So that when we look at this right here, this b, that's the area of the base. Since my base is a triangle, I want to use the triangular area formula of 1/2 times the base times the height of that base. But then remember that this h right here is the height or altitude from this tippy-top vertex of the pyramid straight down to the base. It's a perpendicular distance that gives me 7 inches as well. So the pyramid is as high as the triangle is, right? So remember that height of a triangle is measuring the vertex of the triangle that's opposite of the base, and then it's 3 dimensions, so it also has the altitude up to the vertex. So let's take a look. So the volume is 1/3 of, and then we have 1/2 times 5 times 7. That 1/2 times 5 times 7 is the area formula for the triangular base with a base of 5 and a height of 7, right? So we have 1/2 base times height for the area times 7. So there's lots of numbers there. You can simplify inside the parentheses to get 17.5. So basically when you take 35 divided by 2, you get 17.5 times 7, and then take that whole product and divide by 3 to get 40.8 centimeters cubed. Make sure that you can get those numbers to work out in your calculator. Let's go ahead and try this. Find the volume of this figure. In this case, it does look to and appear to be a square pyramid. So I'm going to give you a few minutes to go ahead and calculate the volume of this pyramid. Okay, let's take a look at this problem. So if we start with the formula, 1/3 of the area of the base times the height. In this case, we have the area of the base is 4 times 4. That can simplify to 16. 16 times 8, and then divide by 3 will give you approximately 42.7. We talked about that this case has a repeating decimal, 0.6 repeating. So if we're taking it to the 10th place, it would be a 42.7, and if you have a 6 repeating and we're taking it to the 100th place, you could actually round it to 42.67 feet cubed.